First presenter is Patrick Santz, and there's the remote.
All right, and you just go back and forth.
Should you get it?
No.
Did it work?
Did not work.
There we go.
Oh, it did.
Yep. Yeah, I think you have to push down a little bit more than that. And the red one is the laser.
Okay.
Okay, thanks.
Well, good morning. So honored to be the first one presenting. Thank you for being here. My name is Patrick Santz. My colleague Robert Clark unfortunately couldn't make it today, but I'll be speaking. You guys can hear me? No, I'm not gonna hold that. I'm just gonna kind of push it towards me. All right, can you hear me now? Yeah. Okay. So my colleague Robert Clark couldn't be here today, but I will be speaking on behalf of the both of us. So I'm going to be talking about the benefits and challenges of using Linux in space. So not too long ago, we had a customer that was interested in our single board computer, and we let him borrow one, and he used it, and he thought it was really cool, although he didn't like that we put in an RTOS in it. He actually wanted Linux. And we never done Linux for these type of systems, so it was kind of a shock to us. And this was like full-blown Linux, not even just RTOS Linux. And so we learned some things and kind of wanted to share them. So this, for this particular application, this is a telecommunications satellite. It provides state-of-the-art scalable packet switching solutions for a spacecraft in geosynchronous Earth orbit. Okay, now can you guys hear me even better? Okay. So much of the heavy process, I probably should stand forward. So most of the heavy processing is actually done on the FPGA, as it is mostly done nowadays. But we use the software for a control loop system to kind of tie everything together. So just a little bit of a background on real-time operating systems. So a processor can only run a single thread of execution at any given point in time. However, it is the operating system responsibility to schedule that program and for how long that program is going to be running. So the OS enables multitasking by switching between the running processes. And this is called the context switching. So the context switching latency is the amount of time that it takes for a system to go from one task to the next. And there are two types of operating RTOS. The real time, where deadlines are a suggestion. Mostly they will make it there, but they are not guaranteed. And a hard time, where deadlines are quite guaranteed. So Linux is a general purpose operating system. It's a general purpose operating system that can achieve real time. Linux is open source, so you can modify it and use it freely. It also provides a rich file system support that includes MTD, memory technology devices, and you can use UBIFS, the file system, on top of it. Also, Linux can be ported to a variety of different architectures like x86, PowerPCs, ARMs, MIPS, recently RISC-V. Well, not that recent, but RISC-V as well. So the advantages of Linux, this is mostly why Linux. And well, the first one is no licensing fees. Licensing fees can be very expensive, so this is probably a good plus. The memory separation, you have kernel space versus user space, and each task, each process will have allocated its own piece of memory. And large volumes of free software packages. And that includes file systems, that includes applications like unzip or anything like that, that you don't have to develop from scratch. And there is abundant documentation. This is the one that I like the best, the abundant documentation. I think it's really nice that you can just go on Google and say, how do you do this? And then it just gives you an example, and you're like, oh, okay, then we can, I guess, do that instead of spending like 2 days figuring it out. How do you connect this piece to the next? Because documentation is poorly written. So some of the disadvantages are that it is more overhead. So the context switching, it gives you more latency. You are also going to end up with 2 or 3 times as much code because you have to jump in and out of user space into kernel space. And the latency for interrupt handling. So for a specific system, our implementation was to use, for a Bootstrap, you use Youboot. We use the Linux kernel, the device tree blob, and for the root file system, we decided to go for buildroot. So we decided Youboot because of probably the same reasons as Linux, that it is open source, it is widely used, it has great documentation, it has a command shell where you can just type commands and they just sort of magically happen on the background for you. And you can also make your own quite easily as well. And most of all, that it supports MTD drivers, and you can put file systems on top of it as well. So Youboot is usually stored in non-volatile memory, and it automatically boots by setting, it automatically boots the kernel image by setting the bootcmd environmental variable to whatever it is that you want. So it could be just boot, and then, or like, I think it's bootd to get it from flash memory, and then you will just read it and boot from it. For our purposes, we create our own custom command to load the operating system. And to load Linux, it's divided into 3 pieces. That is the tree blob, the root file system, and the Linux kernel. So we had 3 images that we had to fetch from flash every time. So for our specific command that we created, so we started with bootcmd will call our particular command, and this will mount a UBI file system, and then it will try to look for the kernel image, the device tree blob, the root file system, and then check the integrity of this. If the integrity is good, then it means that we can go and boot, so we will boot into Linux. But if it is not good, then we'll go back and go into the next partition into the MTD and try to fetch the next images. So we had 4 different partitions, and each partition had its own set of images. And I guess if you failed for 4 times, then you just failed completely, and then you just break the system. For our board support package, we're using we made some standard drivers for the 1553 as a character driver, SpaceWire also for character driver, and the NAND flash, we made an MTD driver. The one that was probably most challenging was the 1553. It doesn't quite like to be just a character driver. There's so much more to it than just open, close, read, write, I/O control. So user space versus kernel space. So kernel space is reserved for kernel processes and is not directly accessible by user processes. User space is memory that for user application processes, and the memory is allocated for each process. Memory partitioning requires much more code to manage, as I will give an example in a minute. So in RTOS, it's really easy to just do pick and poke. Sometimes you can just, on the shell, type in the address, and then you get the value back. In Linux, this is not possible. So you have to jump in and out of kernel space into user space. So what we did here is that we created a Linux application that will call a Linux driver. And this Linux driver will dynamically map memory and unmap the memory as you request an address. And we do this through IO remap and IO onmap. Interrupts. Interrupts are also handled way different than in any other system here, because interrupts live in kernel space, and if you want to access them from the user space, you need to implement what is called poll mode. And in poll, you will get some file descriptors in, and these file descriptors will have some flags that say we can either read or write, or also errors. And then once we call poll, there will be a timeout. In that timeout, an interrupt must occur. Let me try to point. Oh. So there will be a timeout. The poll will call the poll function inside the kernel. This is kernel space. And there will be a timeout for that interrupt to happen. If that interrupt happens, then the queue is woken up, and then your code will fall through, and it will return the masks indicating that you can read and write. And then once this happens, in the user space, you can read the event that just happened, and they will indicate you if you can read or write or any other type of flag. And based on those flags, you can decide if you can read now. So this is a way, this is our implementation of how to use interrupts. For latency reduction, since everything is context switching here, what we did is map kernel space into user space. So this is the same driver that I showed earlier. This is our SpaceWire driver. And the difference between the two of them is that here, we are mapping the kernel space, and we're mapping a kilobyte, which is just the buffer. And so whenever your interrupt comes back, instead of just calling read, as we did on the previous example here, we will be calling the piece of memory directly in a for loop, and we just get the data from there. And that kind of reduces the context switching. So some of the takeaways from Linux is that it is open source. It supports closed platform development. There's a separation of kernel space and user space. It has a lot of file systems, like UBIFS that you can use. The only problem is that your code will be much larger, and interrupts are exposed through poll, which means that there will be a lot more latency than on a real-time operating system. And latency can also be reduced through mmap. Any questions?
How long did the port take? How long did it take to get it all running on your platform?
From day one?
Well, maybe day 2.
About a week.
Oh, yes, thank you. For the customer that you had, did they fully understand the scopes of the pros and cons for using Linux?
I think they did. I think that's what they requested. Why Linux? For their application, it made more sense to have Linux because of the packages already available to them. I think that if they would have chosen a real-time operating system, the support for those packages would have been non-existent, and the development time might be a year or two more.
Not so much a question as a comment, but we're seeing the same trend, where we're moving away from RTOS and we're going towards Linux. And we're doing a lot of the exact same, I mean, a lot of that was very familiar to us. So I just think, just in general, that's trend going forward. Have you seen any other customers moving towards Linux as opposed to RTOS? We haven't. I'm just trying to gauge whether it's a general trend or just going to still pipeline.
No, this is the first time I've seen it. I'm hoping that I can see this in the pipeline coming forward, but this is the first for me.
Another question. Have you found anything other than UBI that is shared across a bootloader and Linux? That's exactly why we made the same decision. We have UBI both on the bootloader and in Linux, and so it made it very convenient for our boot process
Are you talking about the file system? Yeah. Like JAFs or X2 and 3?
Right. What we haven't found is really good cross-support across an MTD device that is both supported in the bootloader and in the kernel, where we can set up our kernel images in the room, very similar to what you did. So we've landed on UBI, and that's really where...
I think you're right. I think you're 100% right. I haven't either. That's the same reason why I decided to go for UBIFS. I think MTD pretty much just goes for UBIFS, and then that's it.
Yeah, I don't know if you can actually answer the question, but I'll ask it anyway, and you can feel free not to. But did you or your customer look into the radiation environment and what's built into the Linux kernel to help with that? Or is that still work that's outstanding?
So we have some things, for example, our non-volatile memory is MRAM for the Youboot. So I think we're covered there. That's radiation tolerant. And we have a triple modular redundancy when it comes to the flash. But when it comes to the actual process and how that's still an unknown to me.
And especially RAM.
Yeah, no, that's an unknown to me.
Oh, hang on just a minute. We have one. Let's get this person back here.
Whenever you were determining the viability of Linux, did you ever do any like hard testing between RTOS or like the various other real-time operating systems, or were you just like, oh, it has to go through kernel user space, which obviously increases latency, but it's, you know, how much? Did you ever get that metric, or was it just kind of a, oh, it would increase latency naturally, but not go any further than that?
No, we definitely did run some stuff, although I don't think I can share the data that I got from that.
Okay.
Hang on a minute. Is that Alan? Oh. Just for our online people, we just to make sure we get the microphone.
Could you talk about any experiences you had with, or difficulties you had with going open source?
Are you talking about licensing?
Well, security. Things like security. Customers didn't object to you using open source.
Well, it was a customer requirement to use Linux. It was imposed to us rather than us on them.
Oh, one more. I saw a hand behind you. Let me get to this gentleman here, and we'll finish up with the lady up here because we're almost out of time.
So how about any gotchas for, you know, any experiences you had where you're like, oh, and our thoughts would have, you know, we would have done it this way, but here in Linux, you know, you talked a little bit about the latency stuff, but any other kind of gotchas that you ran into that you could help us understand?
The only one that really comes to mind right now is the code base. It's just so much larger. Like, for example, the pick and poke. I would have done that with one line in an RTOS, but here I ended up with somewhere around 850 lines.
Were there any security concerns around mapping kernel space directly in user space?
Yeah.
Okay.
So I think that the way to deal with that, maybe really wrong here, but let me try to go back on my presentation. So if you do this for the universal pick and poke, you pretty much map the entire processor, and that would be a horrible concern. So this is only done for debugging. But if you do it this way, where you're going to be mapping a piece of memory, you are the one that restricts what piece of memory it can be mapped by using the page frame number and shifting and all that.
Thank you very much, Patrick.
Thank you.